In this video, we are going to discuss how to use the law of conservation of momentum to calculate the speed of an object. Question 7.38. A sledge initially at rest has a mass of 52.0 kg, including all of its content. A block with a mass of 13.5 kg is ejected to the left at a speed of 13.6 meter per second. What is the speed of the sledge and the remaining contents? So here you have a sledge containing a few blocks, and the total mass of the sledge with its content, which you will write as mass of full sledge, is 52.0 kilogram. And initially the sledge is at rest, so we can write its initial speed V initial to be equal to 0. And since its initial speed is 0, initial momentum of the sledge will also be 0. Later, a block of mass 13.5 kg is ejected to the left. So we write mass of the block as mv, which is 13.5 kg. And it is ejected to the left with a speed of 13.6 meter per second. So we write velocity of the block to be negative 13.6. Negative because it is going to the left. When the block is ejected, the sledge will recoil. It will move in the opposite direction. And we need to find the speed v of the sledge with its remaining content. So to solve this, we are going to apply the law of conservation of momentum. The law of conservation of momentum says that in an isolated system, the total momentum remains constant. That means initial momentum has to be equal to final momentum. Initial momentum of the sledge is 0, as initially the sledge was not moving. Final momentum will be sum of momentum of the block, which is mass of the block into its velocity, plus sum of momentum of the sledge with remaining content. So we can write it as mass m, which is the mass of the sledge with remaining content, into the velocity v. This mass m you can calculate by subtracting the mass of the block with the mass of the full sledge. So I can write m as mass of full sledge minus mass of the block. Now let's rearrange the term to calculate for v. I will move this to the other side. So we get negative mv vb equals m times v. I need to find what is v, so let's divide by m. V will be equal to negative mb vb over m. Substitute for m from here. I write this as negative mb vb over mass of full sledge minus mass of the block. Now let's substitute the given values. Mass of the block is 13.5. Velocity of the block is negative 13.6 over mass of the full sledge is 52 minus mass of the block, which is 13.5. And when you solve this, you get the speed of the sledge with the remaining content to be equal to 4.7688 meter per second, or you can round this off to 4.77 meter per second. This value of velocity is positive because the sledge is now moving to the right as the block was ejected to the left. Question 7.39. Stuck in the middle of a frozen pond with only your physics book, you decide to put physics in action and throw the 5 kilogram book. If your mass is 62.0 kilogram and you throw the book at 13.0 meter per second, how fast do you then slide across the ice? Assume the absence of friction. So here in this question, you are initially in the middle of a frozen pond with your physics book. Your mass you can write as m, which is 62 kilogram. Mass of the physics book is mp, which is 5 kilogram. The speed with which you throw the book is 13.0 meter per second. This we will write as the speed of the book. And this speed will be positive as you throw the book to the right. Once you throw the book, you will be pushed in the opposite direction. So you need to find with what speed you will move across the ice. So I need to find the final speed for the person. Again, we are going to use the law of conservation of momentum. We know from the law that initial momentum has to be equal to the final momentum. So we write P initial equals P final. Initial momentum is the combined momentum of you with the book, which is zero as initially you are not moving. So P initial is zero. Final momentum will be momentum of the book plus your momentum. So mass of the book with velocity of the book plus your mass with your velocity. I need to find this velocity v. So let's move this to the other side. I get negative mbvb equals m times v. We need to find your speed. So let's divide by m. V becomes equal to negative mbvb over m, where mb is the mass of the book and small m is your mass. Let's substitute to calculate the velocity. Mass of the book is 5. Velocity of the book is 13. Your mass is 62. And when you solve this, you get the speed with which you move on ice to be equal to negative 1.048, which you can round off to negative 1.05 meter per second. So this is the speed with which you will move on the ice. The negative sign indicates that you move in a direction opposite to which you throw the book.